So now in this video, we are going to use a comparator. It's not an op amp, it's a comparator, LM393, right there, wired as a non-inverting comparator. So right now the output's actually high, the LED is off. We have to get the output low to turn the transistor on to turn this LED on. So this is a brighter LED than I normally use. It's a 1 watt LED right there. I'm not going to use the 2N2906. The 2N2907 can switch about 600 milliamps of current. I always make it so it can switch, quite a bit more than what you're actually going to switch. When it comes to the base resistor, we got a lower value resistor because we need more current for emitter to base than normal right there, because we got about 200 milliamps of current going through. When I turn the light on, you can see now that LED turns on, and it's fairly bright right there. And now I turn the lamp on, and the LED is off right there. As you can if I put my hand over, that's still not dark enough. I have to even my finger right on there. So we got to actually turn the lamp off in this case right there. Not turning on at all. I thought it would. But in case you saw it turned on. And so we got that. We're using light dependent resistor, voltage divider. And last video I used a trim pot and just a regular LED. So had a higher value base resistor and a transistor that can't switch as much. The 2N3906, which is really commonly used. If you need more power, more current actually, 2N2907 is basically the PNP version of the 2N2222, which can also switch 600 milliamps of current. But when you need the PNP version, you can use the 2N2907. So this is a module right there. It has an LED, a 1 watt LED, and a resistor already built on it. So you put 5 volts across it, and really only 5 volts, like maybe lower, but you don't want to go higher. It's made for 5 volts. Here is the pin layout for the LM393, and it does not have a high and low output like you normally do with like op amps. It can connect to ground when it's low, and that's it. It's off otherwise. So we need a pull-up resistor. So we're using the one on the left. Nothing seems to go wrong if we leave the right one floating. So we're going to, but you need to power it. Positive to pin 8 and negative to 0 right there. I always got to do that even if it doesn't show it on the schematic. Positive to 8 and then negative supply to 4, ground. There's our pull-up resistor, our 1K resistor for turning the PNP bipolar junction transistor on and off. So right now we have a high input right there, holding it off. This is off. It's not connected to anything right there. When we get it dark enough, again, let's lower the lamp. There we go. Now, if I cover it, it's dark enough. We have, actually, I don't think that was even dark enough to turn it on completely right there. But yeah, now it's dark enough. It is on. That's because we had a low input when I covered this and it got dark enough. Low input there. It's lower than our reference voltage, so we have a low output. It's connected to ground pretty well. So now, since we're using an open collector output there, which is basically an NPN bipolar junction transistor that's either on or off, even though if I get like a middle ground voltage, it does seem like it doesn't quite turn on fully, so we don't get the full current. But in any case, the pull-up resistor helps make sure we get 5 volts to solidly turn that off, because it's an NPN bipolar junction transistor in the output. Makes a really good connection to ground, but you should still limit the current to about 16 milliamps of current, according to the data sheet that I saw. So you can power somewhat of a load with the low output right there, but you can not power, with the pull-up resistor. It's just to help, lock things off for the most part right there. So there's the part number there, 2N2907, and to look at the current, we will pull back. And I'd probably have to turn the light on this right there, even though it's not going to show up too good. There you can see we got 0.197 amps right there, 200 milliamps of current. So normally I keep the power supply set to a maximum of 20 milliamps of current, but we need much more right there. So I set it to a maximum of 300 milliamps of current right there that we can get. And that display should show up better right there. So if I do short circuit something or miswire something, we're still going to limit to 300 milliamps of current, which may fry something, but not as bad as it could be if I set this to a higher current. So you should limit current to, somewhat close to the maximum you're ever going to need with the particular circuit you got there, just in case something goes wrong. You don't get higher, much higher current than that. So in any case, rambled on long enough. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.